Hello, my name is Sven. I'm the founder of Synamic Technologies. Today, let me introduce to you our Scribe project, which has been funded by the ELISE Consortium for Artificial Intelligence. Our project is about automating cybersecurity.
In Scribe, we extract attack graphs from threat reports using natural language processing and transformer models. Attack graphs are the characteristic fingerprint of a cyber attack. They describe how attackers proceed to reach their goals. We will come back to this slide later in the presentation. With the technology developed under the ELISE grant, these attack fingerprints are extracted from text using artificial intelligence. They can be processed automatically for attack detection, prevention and protection. This is the MITRE ATT&CK framework. It describes all known hacking techniques that are used by cybercriminals. During the past years, our company has been building a cybersecurity knowledge graph around these techniques. The Scribe project is based on this knowledge graph and enriches it with up-to-date threat intelligence. This allows us to create an early warning system for our customers. Let's see how it works. Look at a sample threat report. It is not important to read all the text. Let us rather focus on a specific phrase. Contains the malicious code which executes a VB script. This is obviously about the attack running commands on the victim's PC. Scribe technology identifies this phrase as containing information relevant to a technique during the attack. For this task, we trained a BERT model specific for cybersecurity jargon. Our multi-label classifier then identifies the technique and the attack framework. In this case, it is the use of a command and scripting interpreter. The technique is known as T1059 in the taxonomy. Of course, our threat report contains more than one technique. Cyber attacks are a complex chain of events. Only with a full picture, detection and prevention is possible. Scribe identifies all of them in the proper sequence, forming the attack graph. The edges and the nodes are data points following a clearly defined ontology. It is based on industry standards. This allows for sharing and integration with other tools. We are able to provide the output in STIX2 data format standardized by Oasis Group. For the representation of complete attack graphs, we are using an extension to the standard that has been developed in our project. Now let's look at this in practice. This is our web UI where you can enter the threat report. Our intention was to keep the user interface as simple as possible and let the AI do the rest. So the only thing you need to do is to paste in your text here. On submission, Scribe will extract the techniques referred to in the document. We are currently focusing on the top 30 techniques. The tool will also recognize the so-called indicators of compromise that help security professionals in detecting an attack. Our front end also features a visualization of the attack graph. This allows the user to gain an intuitive understanding of the complexity and the different attack steps. We have just seen how Scribe extracts an attack graph from a textual threat report. It identifies the individual steps during the cyber attacks and maps them onto the MITRE framework. Our technology has various applications in the domain of cybersecurity. First, it can be used to create an early warning system for upcoming threats. Also, Scribe can be used to automate the processing of threat intelligence. With the increasing reporting as under the EU ELISE directive, our technology can help to process and assess these reports based on artificial intelligence.
For our project, special thanks go to our scientific advisor Christian Kersting and the ELISE Consortium. You did so much to make it happen. Thank you.